And Joel is the leader and former of Splash Modular, and has now developed his Revea platform, which I think is quite an exciting step forward in configurators for industrialized construction. So with that, Joel Hutchines, founder and CEO of Splash Modular.
Thanks, Daniel, and thank you for having me. It's great to be here amongst some great presenters and other companies, and it's pretty hard to follow up with Intelligent City and Oliver before me. They are very impressive, and I love seeing what's happening in the industry and how parametric design is driving us forward. So as Daniel mentioned, I'm the founder and CEO of Splash Modular. I think it's probably a good time to sort of address the confusion behind Splash Modular and Revea. We started off as Splash Modular, and we really pushed the bathroom pods as far as we could, but we used that vehicle to showcase how we could push our approach. And it's now time that we're starting to fade out of the bathroom pods and really focus solely on the Revea platform, as Daniel mentioned, and bringing that to market. So today I'm just going to walk through our process and how we created Revea and the idea of a customizable digital product. But I'm sort of going to tie that back into how we've analyzed the industry, and through my career path as a carpenter, builder, and architect, and then really into industrialized construction, how I've noticed some real shortfalls in why industrialized construction is yet to sort of hit its strides, or yet to hit its full potential. So just like I guess many other people have in the past, I'm going to start with this slide, right? It's the McKinsey report. We talk about how construction isn't as productive as other industries, and we've consistently sort of compared ourselves to those industries. But what this did for the industrialized construction is really brought us to the forefront. It brought us to the forefront in terms of a solution to industrialized construction, and to sort of bring us into the digital age, or into that mass production age. But what we did see was everybody start to promise better, faster, and cheaper. And I don't think that I can stand here and say that we haven't achieved that, but I don't think that we've hit our full potential. I think that there's a lot of companies still out there saying that we are better, faster, and cheaper. And that's mainly because we are, but not to our full potential. We're better because we have this great technology. We have this great machinery. We just saw Intelligent Cities robotics there. We have a myriad of available technology and machines. But one thing we never really discuss is that every machine really takes its own language, or it takes its own knowledge, or its own even software platform most of the time. The CAD/CAM process is really not spoken about too greatly. Faster, yes, we're faster. You know, there's the obvious there that we actually bring things off site, and we have that crossover. But what I'm going to sort of touch on today is the process and the workflows, and that's why we're really not seeing the full potential. We're not as fast as we possibly could be. And then cheaper, it relates to that. We're consistently saying that we're cheaper because we're tying that back to the sort of quality and the time. We're not really tying that back and having a comparable sort of cost there. So I'll jump in, I'll go through the workflow and the process. As I said, in my sort of career path, one thing that's really driven me a little bit crazy is the idea of architects and design intent. We've focused so much on, you know, even in our pedagogy and our schooling, we focus on drawings and producing design intent and how that passes on. So right now, I'm just going to outline a sort of traditional pre-construction phase in construction, and then tie that back into industrialized construction. So design intent, and then we go to consultants. We have this level of documentation to be able to even express what we are intending to design, or we're starting from that clean slate and we're trying to bring that to life. But we've got this, what I show here is this very sort of linear and progressive nature, but in actual fact is this sort of crossover and this collaboration where we're constantly striving for the feedback and the information while we produce that documentation. One of the funniest things really is we talk about BIM, we talk about prelims, and we talk about estimating, and this data flow, and we're producing design intent, and then we're reanalyzing it. And before sort of we started talking about 5D BIM, or we started talking about that level of data, we were still talking about design intent, producing drawings and interpreting it, and then trying to relay that to get to that cost estimation. But it is still a guess, right? We don't actually get to our costs until we start to bring in the subcontractors in the supply chain. We live in this world of, let's produce the design intent, document it, and then bid and tender it. We have no two-directional data flow. And where we really need that feedback, we don't have it. this produces sort of a value engineering process. And for industrialized construction, too often are we bought in at that level, and then we're fighting with that value engineering process to actually make ourselves also stay relevant. You know, on site, we just figure it out as we go. That's sort of traditionally how we do it. You've only got to walk into any building these days and you can still see the amount of drawings where they're figuring things out with a pencil on the wall. So one thing I wanted to sort of highlight here is that, yes, we've taken that process of taking what was on site and we've taken it off site, which allows us to bring it in. We see the immediate cost savings. One thing that we rarely do discuss is the fact that with industrialized construction comes this form of this need and this added effort that we have of this early contractor involvement, or what we need to put into the pre-construction to actually make the industrialized construction real or to see it to come to fruition. We're constantly pushing on the design intent and trying to guide that intent to include that industrialized construction or that offsite. We're then looking at the documentation and we're looking at how we actually make the feedback or the software flow or that software stack to actually get the relevant geometry or the relevant data back out. But then we're adding this extra layer in terms of prelim and pricing and costing and scheduling, because it's never really thought of and it's having to be developed along the way. So what this has led in the industry is this standardization. We look around the industrialized construction sector and we're all talking about standardization. We're all having this debate versus product versus project. And really, we've got to productize, and we're looking at chunks of the building and how we productize that. And I see we've really moved. Yes, we've had that in BIM and BIM objects and this idea on the material level, but we're now starting to see on that system level. And I guess Intelligent City are a prime example there. If they weren't leveraging the parametric design and they weren't leveraging the technology here, they would be preaching this standardized element and complete standardization. And for me, that becomes fearful. I become fearful of that when we start to talk about the full level, the full building level. But, you know, it makes sense. The reason we're doing this is we've got the product and the economies of scale. The more we produce of that product, the lower the cost. Right? We sell 1, 2, 3, we sell 100, we're now starting to see some benefits there. And now we're starting to see cost. And so I don't blame the industry for going to standardization, because that's the way that it's evolved. And that's where we've seen that this extra workflow, this extra effort, we need to offset and have the economies of scale. But one thing that I am fearful is that we're not really taking into account the project data. The idea of this dynamic data set that's going to need change. It's going to mean that how these buildings come together, we're going to have to adapt them and we're going to have to change certain elements, and what that's going to do, right? Well, there's so many areas that can change. Site is a big one. In architecture, we talk about site context a lot, and we talk about these habitable buildings. I feel that if we preach too much standardization, we're going to end up with boxes that energy sapping boxes that are uncomfortable and no one wants to live in, if we go too far to one extreme. So as we analyze where this is going and how this ties back into software, we're looking at the industry starting to create BIM objects. And those BIM objects, they're taking that 3D object or that 3D representation, they're tying all that data and that workflow and that process to it, and they've got a static BIM object. And what they're then doing is we're creating these static BIM objects, and then we're creating a library of these objects, and we're calling this our kit of parts. And we're consistently trying to look through this library or this kit of parts to try and make predefined elements work. But in actual fact, we don't have that liberty. We're taking that and we're plugging that in, and we're providing the data and the design intent and the design documentation, and thinking that it will just alleviate that and we can tighten it up. But once again, we're not taking into account that project data and this need for change, this need for all of these other dynamic data sets that are going to come in and influence the change in the very smallest detail. So, you know, we don't end up any better. We've just now got this collaborative approach where we're just constantly looking at the inefficiencies in the process, and we're never actually striving or moving forward. So for us at Splash Modular, this became about how do we create a dynamic object? How do we actually take that object but tie the workflow to it? And then we can create this dynamic, customizable, cool object that can actually adapt to what we need it to do. So as we look at the workflow, that's the parametric workflow. So we're taking that step by step to creating that product, and we're computationally, algorithmically generating that so that we don't have to do it again. So that we're looking at the inputs on one side and we're looking at the outputs. So we can have a range of inputs and a range of customization or elements that we can change, but we can automate and have the outputs come out the other side. So we did that with the bathroom pod, and that's really where we started to progress. But we became obsessed with this idea of product, right? And we wanted to move forward to a customizable digital product rather than just a dynamic object. So that's where it went back to inputs and outputs. But this time we made it about supply chain specific inputs. So we weren't just putting in inputs to create an arbitrary 3D object again. Now we were starting to look at the manufacturing constraints, the logistical, the supply, the material, engineering, costing. We were bringing everything into account and breaking down the exact workflow of how we created that component and rebuilding it computationally. Now we could load that in there and we could have more automation opportunities on the backside. Now we could start to bring machinery file directly out. So no matter what the input was on the outside, on the front end, we could automate the delivery of that on the outside. We could look at logistics, supply chain, approval drawings, shop drawings, whatever we wanted to automate, we could start to add more and more. We could look at efficiencies. We could really drive that process forward because what we'd done is we'd laid the foundation for us to start to build upon. So for us, that's really the design for manufacturing and assembly. When we talk about that, we're talking about how we break that down to understanding exactly what can be achieved. And then we're rebuilding it. We're understanding the confines of it completely. So if you take the iPhone for an example, we're not just saying that it can only be this size of screen. We're looking at what the machine can actually do, or what it can produce and what are the confines, and we're rebuilding it that way. So that really became to us is about the product became the process. How do you're owning the process? For us, we didn't have to own the infrastructure. We didn't have to own the manufacturing. We could decentralize the supply chain, but we would own the process. We could build this process. And then when we came to a problem or when we came to building in more options, when we had a project that needed it, we'd build in those options. So when we built in those options, we bridged it. And so we had what I like to use the analogy here of the neurological network or the neurological path. What we did is we didn't learn how to walk every day. We taught ourselves how to walk, and then we came across an obstacle. We learned that we could go over it or we could go around it, and we built that in. So as we built all of that in, we now had this, we could create a neurological path. We could have everything built into the process, protect our IP, not hold the hands of the architect to be able to do that, but we could actually let them make the decisions with all the information up front, but protecting ourselves. So take that logic and put it on the cloud computing, leverage cloud computing, keep everything in the script and in the metadata. We could then take the inputs that we wanted to be able to make adjustable and turn them into a configurator, to have the architect now use a configurator or use a step-by-step guide, whoever you wanted to dress that up, to be designing within the confines of what's achievable. Mass customization, right? So designing within the realm of what's achievable, and then we could benefit from that and automating on the backside. The next step for us was really, how do we take that component and make it digitally aware? So when we created a multi-trade assembly like a bathroom pod, we took things like the vanity and we created our own parametric workflow for that. We built in inputs and outputs so it understood itself in a digital context. So when we moved the vanity, we knew that it would adjust the framing. It would adjust or it would generate the plumbing, and the plumbing would then adjust the framing. We'd never had to worry about clash detection because the systems or the workflows were working in tandem. They were working together. Right the way down to, we could then benefit and build upon that to have our CNC cut sheetrock. We could have the system work with that. We could mark fixings. We could have fixings and framing, and everything will start to work together. And now we created our own customizable digital product, which is a multi-trade assembly made up of everybody else's customizable digital products, which were the individual components.
Joel, so for us, jump in. We're at the 1 minute mark. So
okay, I'll finish up here. So just finishing up here, what we've now identified is that we've really seen a divide, and I will apologize to Hyper and Ian here, where I have positioned you over there on that generative design automation, but we've seen this ecosystem grow apart, and we've seen two sides. We've seen generative design, and we've also seen project delivery automation. And what we're seeing in the middle is we've been there. So we've got very data-driven generative design working on site feasibility and massing. But what it needs is now it needs digitally aware components or fabrication or supply chain aware components that can actually guide it and create something that's actually buildable. And then we need that data flow, that two-directional data flow, to feed back to the other side to automate the shop drawings, but then come to the other side where we need it for smart contracts or for construction management or anything like that. So what we've really seen is if we go out and we digitize the supply chain and we do this for everybody, creating a new system of component, now we can really start to see the industry move forward together. So we do see ourselves here really as not the end-to-end platform, but unlocking it through feasibility, through design, construction, and even life cycle. So what can this do for the actual digital twin? Now we can get to the level of understanding things at their fabrication or their supply chain level and keeping that consistent the whole way through. It's almost like a new way of designing, but a new operating system for construction. I do have a video here showing you a little bit into Revea, but we'll cut that out and we'll finish up there.